Welcome to today's paper reading. Today's paper is titled, Bi-directional Contextual Attention for 3D Dense Captioning. This paper was published on AR14 by Minjung Kim and colleagues from Seoul National University and LGAI Research. The abstract introduces the concept of 3D dense captioning, which involves the localization of objects and the generation of descriptions for each object in a 3D scene. It highlights the challenges faced by recent approaches, such as limited contextual information and contradicting objectives between localization and description generation. To address these issues, the authors propose BICA, a transformer encoder-decoder pipeline with bidirectional contextual attention. This method improves caption generation performance by enhancing localization and aggregating contextual features across the global scene. Experimental results show significant improvements over prior methods. 3D dense captioning involves identifying the positions of objects within a 3D scene and creating descriptive sentences for each detected object. Early methods used a two-stage approach, detecting objects first and then generating captions. However, these methods face challenges in capturing sufficient global context and balancing local and global features. To address these issues, the authors propose the Bidirectional Contextual Attention (BICA) network. BICA employs a multi-stage pipeline with bidirectional attention to effectively aggregate context features without compromising localization performance. This approach sets a new state-of-the-art in 3D dense captioning and improves object detection performance. Figure 1 provides a conceptual illustration of the multi-stage pipeline of BICA, a novel approach for 3D dense captioning. The pipeline leverages bidirectional contextual attention to enhance the generation of descriptive sentences for objects within a 3D scene. It operates by parallelly decoding instance queries, which focus on individual object features, and context queries, which capture non-object contexts and positional relationships. This dual approach allows BICA to effectively summarize relevant context features for each object and aggregate object features relevant to the summarized contexts. The multi-stage contextualization process ensures that captions are generated with both local and global contextual information, improving the overall performance of 3D dense captioning. In the field of image captioning, deep learning models have become prevalent, utilizing an encoder-decoder architecture. Attention-based methods focus on specific image regions and use advanced techniques like graph neural networks and transformer layers. On the other hand, 3D dense captioning involves converting 3D visual data into natural language descriptions. This process includes a scene encoder, a relational module, and a feature decoder. Despite advancements, challenges remain, such as the use of a single query set for both localization and caption generation, which can lead to conflicts. Improvements like Vote2Cap-DTR++ aim to address these issues by decoupling queries, but performance is still dependent on precise object localization. The authors introduce a novel transformer encoder-decoder approach with bidirectional contextual attention for the task of 3D dense captioning. This approach is designed to distinguish between features for individual instances and context information between instances. By doing so, it indirectly supervises the context features to enable end-to-end learning alongside the instance features. The model generates two sets of queries: instance queries for localizing objects and capturing their characteristics, and context queries for capturing non-object regions and positional relationships within the 3D scene. This parallel generation and decoding of queries allows the model to effectively capture the complex relationships between objects and their context in a 3D scene. Figure 2 illustrates the overall pipeline of BICA, which involves parallel generation and decoding of two sets of queries, instance query and context query. These queries encode instance features and non-object context features across the global scene. The object-aware contexts are determined by the weighted sum of context queries, with weights derived from the attention between decoded instance queries and context queries. Subsequently, the context-aware object feature is obtained through the weighted sum of instances, with weights based on the attention between object-aware contexts. This approach enables BICA to effectively capture and utilize contextual information for improved 3D dense captioning. In this section, we discuss the datasets and metrics used for evaluating our 3D dense captioning model. We leverage two benchmark datasets, ScanRefer and NR3D. ScanRefer contains 36,665 descriptions covering 7,875 objects within 562 scenes, while NR3D has 32,919 descriptions for 4,664 objects across 511 scenes. Both datasets are sourced from the ScanNet database, which includes 1,201 3D scenes. For evaluation, we use four metrics: CIDR C, BLEU4, B4, Meteor, M, and Rougel R. Additionally, we employed the M at K metric with IOU thresholds of 0.25 and 0.5. The implementation details include a three-stage training process, using the Atom W optimizer with a cosine annealing schedule, and specific batch sizes and learning rates. Figure 3 provides a detailed visualization of the stages in the 3D dense captioning model. It begins with the input 3D scene, A, and the corresponding point cloud without color, B. The visualization of instance queries, C, shows the spread of queries across the 3D scene, not focused on specific objects. A sampled instance query, D, is then shown, followed by its geometry contextualization, E, highlighting the surroundings and distant corners of the room. Finally, the instance contextualization, F, depicts related instance queries for the object-aware context feature, demonstrating the model's ability to check all instances to generate captions for a single object. Figure 4 presents qualitative results from the ScanRefer dataset, illustrating the effectiveness of the proposed method in generating detailed captions for 3D scenes. The yellow highlighted sections in the figure provide information specific to individual objects, such as their attributes and characteristics. Green highlights describe the relationships between different objects within the scene, showing how objects interact or are related to each other. Blue highlights focus on the spatial positioning of objects, indicating where objects are located in the 3D space. Captions that are underlined in red signify incorrect descriptions, while FTG denotes failures in caption generation due to low intersection over union IOU scores. This figure effectively demonstrates the model's capability to capture detailed and contextually relevant information about objects and their relationships within complex 3D scenes. Table 1 presents the experimental results on the ScanRefer dataset, which evaluates the performance of various models in generating captions for 3D objects. The metrics used for evaluation include CIDR, BLEU4, Meteor, and Rougel. Our method, BICA, demonstrates superior performance across all metrics and IOU thresholds, achieving the highest CIDR score of 89.72, BLEU4 score of 44.97, and Meteor score of 28.96. This indicates that BICA effectively captures the attributes and spatial relationships of objects, leading to more accurate and descriptive captions. Table 2 presents the experimental results on the NR3D dataset with an IOU threshold set at 0.5. The table includes metrics such as C at 0.5, CIDR, B4 at 0.5, BLEU4, M at 0.5, Meteor, and R at 0.5, Rougel. These metrics evaluate the performance of various models in generating object descriptions. Notably, the BICA model demonstrates superior performance compared to other models, highlighting its effectiveness in this context. Table 3 presents an ablation study on the ScanRefer dataset, focusing on the core components of the BICA method. The study highlights the importance of three key components: the decomposition of the query set into instance query VO and context query VC, the object-aware context feature VCA, and the context-aware object feature VOA. These components are shown to significantly contribute to the final performance, as evidenced by the performance metrics in the table. The study demonstrates that each component positively impacts the model's ability to localize and describe objects in 3D scenes, enhancing the overall dense captioning performance. The BICA model is a novel end-to-end transformer encoder-decoder pipeline designed for 3D dense captioning. It incorporates multi-stage contextual attention to enhance its performance. BICA uses object queries to capture local features of individual objects, and context queries to include non-object contexts in the 3D scene. This dual approach allows the model to consider both object-aware context and context-aware object features, improving both localization and captioning accuracy. The model's effectiveness has been validated by its superior performance across all metrics on two major benchmarks for 3D dense captioning, outperforming the current state of the art. Thank you for watching.